Okay, so we come back with section 10.2, rational exponents. Um, in this section, we would talk about when I have an exponent in a rational form. We have learned that. Let's say remark. I have something such as like a product rule. A power m times a to power n will be equal to a times m plus n, right? Everyone still remember for the power rule, a product rule, this is when you have the same base, different power, you just can keep the base and then adding the power. So let's take a look at an example as 4 to the power 1/2 times with 4 to the power 1/2, and let's see what happened. I'm gonna have 4 to the power 1/2 plus 1/2, and that will give me 4 to the power 1 with equal to 4. So what is in the idea right now? You can think like, oh, something multiplied by itself, 4 power something that multiplies itself over here, and get a number 4, right? So is that going to be similar as square root 4 times with square root 4 going to be equal to 4? So that means what? That means square root of 4 can be rewritten as 4 to the power 1/2, right? As I state this rule in previous section, but I just want to make sure from now on you guys can remember that for a to the power 1 over n is actually equal to root n of a. Okay, so everyone should remember this formula, and for a is a real number, and n is an integer. So n has to be greater than 1. Okay. So let's do some example. Here's example 1, and now come to example 2. Say a 36 power 1/2 will be square root of 36 equal to 6. Easily, right? B, I have x power 1/3 can be rewritten as the third root of x. Okay. And yeah, I think that I have another one as 5x to the power 1/2. How can I write this? This is going to be square root of 5x. Easily. Now, let's talk about an expression. So the expression a to power an m over n. Okay. For this one, is actually gonna be equal to the root in here is the index of the root in here should be the denominator of the power, which is n, right? N. And let me just put n over here. And the radical is a to power n. There is another way to write is root of n, radical is a, but everything now is to power n. Okay. So please remember this formula. So let's have an example 2. No, 2 or 3. 3. I should say that for A's, let's say for A is all real number. No, for A, okay. Or A can be all real number. N and M integer positive. Okay, so let's move to example 3. Have say 2 to the power 3, 4. Will we rewrite as root index here is to be the denominator 4, right? Of 2 to the power third, right? Another way is root 4 to power everything to power third. Everything to power third, right? Okay. Okay. So if I have B negative 27 2 over 3, and I want to express evaluate this expression. Okay, so how can I do? Let me rewrite this as a cube root, right? Because the power, the bottom, the denominator of the power is 3. The negative 27, everything to power 2. And I can rewrite this as cube root of negative 3 to power 3 is sine, and everything here to power 2. And you can see that the cube root here can cancel by the power 3 inside. And you're going to have now just have negative 3 and the power 2 stay. And that the result is going to be equal to 9. Okay. Or you will rewrite it as in another way as negative 27 to third will be equal to, say, the cube root of negative 27 to the power 2, right? I can change it to become the cube root of 7 to 9. And the cube root of 7 to 9, you can change it to become like the cube root of 9 times 9 times 9. And that will give you just 9, a number 9. So that can tell you that, oh, even either way, that still give you the same result. Okay. Okay. So move to I want you guys to note that for A is less than 0. For A is less than 0. And N, or the denominator of the power, right? Okay. And let's see. Let me make sure. Oops, where that's. N is even. Then the radical then then I'm going to say a to power m over n is not real number. So you want to make sure you guys should remember this. Okay. So let's move to the let's see. Let's move to another expression. Say the expression a to negative m over n. What happened with this form? Okay. So you can change this to become 1 over a to power m over n. For a not equal to 0, and what else? And m and is positive integer. So you should also remember this form. And for example, right? What is 4? So you write each expression in radical notation and evaluate. So 2 things. Okay, let's do A. have 64 to the power negative 1/3. What you do is you're going to convert it to be 1 over 64 to the power 1/3. And then you're going to apply the bottom and change the bottom to become the root of 60, root number 3 or cube root of 64. And if you use by hand, you're going to have 1 hour cube root of 4 to the power 3rd, which equal to 1 over 4 as the answer. B, I have 81 to the power negative 3/4. You will change it to become 1 over 81 to the power 3/4. And now I can rewrite the bottom as 4 root. The index bottom, the index is the norm of the power, right? So I have 81. Yeah, just gonna put 3 outside over here, and then you have 1 to the power the 4 root of 81 gonna be equal to 3, so you're gonna have 3 to the power 3rd, and then 1 over 27 gonna be the answer. Okay, let's have C. Say the you know what? Let's have examples 5. Converting to rational expression. Sorry, rational exponent. Okay, so let's say A. Root 5 of x to the power 4 will be equal to, if you convert this to a rational exponent, make sure the index will be the denominator of the power. So put x, write out x, right? And the power, bottom is index 5. Top gonna be 4. Okay, so that it. And B, let's say 1 over square root of b to the power 5. I can convert it as 1 over b to the power 5 over 2, because the square root is hidden in index 2. Okay, so now I can convert this one more time and rewrite as b to the power negative 5 over 2. All right. C. I have, let's say, the cube root of a squared plus b squared equal to a squared plus b squared, having to the power 1/3. You cannot, you have to stop here and note that a squared plus b squared to the power 1/3 cannot equal to a square, I mean a to the power 2/3 plus b to the power 2/3. Okay, maybe someone gonna think that, oh, for this case you're just gonna multiply distribution the power. That's totally wrong, so don't make that mistake. Okay, so I would love to remark some properties of exponent. So let P, Q are rational number. And A, B are all real number. So I have, say, 1, A to the power P times A to the power Q can be rewritten as A to the power P plus Q. Okay, this is called a product rule for exponent. Okay, 2. A to the power negative P will be equal to 1 over A to the power P. And in another way, 1 over A negative P can be rewritten as A to the power P. This is called a negative exponent. So 3 A over B, everything to the power negative P, can be rewritten as B over A, everything to the power P. So you flip the bottom and the top of the rational. Okay, so that is the first 3. Let's move to number 4. I have A to the power P over A to the power Q. That's going to give me A to the power P minus Q. So this is called quotient rule. And number 5, I have A to the power P, everything to the power Q will be A to the power P times Q. This is called power rule for exponents. And then number 6, A times B, everything to the power P will be equal to A times P, A to the power P, and B times B to the power P also. And this is called power rule for product. And number 7, the last one, I have A over B to the power P can be rewritten as A to the power P over A B to the power P. And this is called power rule for the quotient. Okay, so all of these is called properties of the exponent, and I hope that you guys should deal with this, all of these 7 properties, because that's important for the exponent and the radical expression. Okay. Let's do an example. Okay, okay, so example What example we are right now? 5, right? Yeah, so let's do example 6. So we have what we're doing, write the answer with positive exponent. Okay, so let's do part A. I have square root of x multiplied by the cube root of x. So we're gonna have what? This equal to x power 1/3. No, sorry. It's x power 1/2 multiplied by x power 1/3. Right. This is a rational exponent, right? And if you apply the product rule, you can have x power 1/2 plus 1/3. That can give you x power 5 or 6 when you simplify, right? So let's do, say, another example. Cube root of 27 times x squared. Okay, so for this one, you can firstly convert the cube root become 27x squared, everything to power 1/3, right? And apply for the power rule for the product. You're gonna have 27 1/3 time with x equal 2, everything to power 1/3. This is called power rule for product. Okay, so now you will have 27 over 2 power 1/3 will be equal to 3. And for the x square power 1/3 will be x power 2/3. And this is called power rule for exponent. Okay, that's the answer. So this is the answer. Okay, that is B. And let's see, I'm gonna have C. As x squared over 81 to the power -1/2. I can firstly change it to become the positive power. So that will be 81 over x squared and 1/2, right? Secondly, if I apply for the power rule for quotient, then I have 81 to the power 1/2 over x squared, everything to the power 1/2. And that will give you 81 to the power 1/2 will be equal to 9 divided by x squared to the power 1/2 will be x only. Apply the power rule for exponent. Okay, let me, here we go. Okay. Let's have one more, no, some more. So D, I have let's say cube root of a square root of x plus 1. Okay, so look like, oh, this one is crazy, right? So how can I do this one? Just, change it to become the power, change it to become the exponent 4. And you have, say, first step with the cube root, it's going to change to be x plus 1 square root, x plus 1, everything to power 1/3. And now I'm going to change the square root to become x plus 1 to power 1/2 and everything to power 1/3. And lastly, you're going to just apply the power rule for the exponent. You're going to have x plus 1 to power 1/2 times 1/3 is 1/6. Okay. E, I'm going to have, let's do y to power negative 1/2 over x to the power negative 1/3. And now, how can I do this one? Firstly, I would love to convert it to become to convert all the negative power to become positive power. So the top now move to the bottom, become y to power 1/2. And for the bottom, x to power negative 1/3 and become move to the top and become x to power 1/3. And I'm gonna just stop here because you cannot simplify. This will be the answer also. So here's E, right? And then F. The last one I have square root of x times with square root of x minus 1. Now I'm gonna convert all these in the form as power or exponent. X to the power 1/2 times x to the power 1/2 minus 1. That will give me, using the distribution rule, you will have x to the power 1/2 times x to the power 1/2 minus x to the power 1/2. And lastly, you will have x power 1/2 times x power 1/2 will be x power 1 minus x power 1/2. Add the answer. Okay. So that's all I need to teach you for this section 10.2, and I will see you on the next day. And we're going to talk about 10.3 later. See you later.